Okay, it's time to talk about our second type of series, and the good news is that this series is no longer tested on the AP exam, so we won't test you on it either, but we wanted to at least show you what it looks like because it's kind of cool. So if you think about an old-fashioned telescope that, you're looking at the moon or the stars or something, and I'm envisioning maybe like a pirate looking at ships. I put these in links because this telescope shrinks down, it collapses when you're done looking through it. So that's what's going to happen to the terms of this series. We're going to write out the terms and they're going to collapse. So when you do a telescoping series, you know it's telescoping because the denominator is linear expressions multiplied together, so linear factors, which tells you that you have to use partial fraction decomposition. So we have to start this by taking 1 over n times n plus 1 and rewriting this as a over n plus b over n plus 1. And then we have to determine what a and b are. So what I like to do is first call n equals 0. And if n equal, first what we need to do is get a common denominator and then just look at the numerators. So I had a common denominator over here already. So I look at the numerator of 1. Here I need to multiply a by n plus 1. And then here I need to multiply b by n. So now I can plug in n equals 0, and this term zeroes out, and I'll be left with a equals 1. And then if I plug in n equals negative 1, this term zeroes out, and I get negative b equals 1, so b equals negative 1. So now I can rewrite my infinite series decomposed into 1 over n minus 1 over n plus 1. So now we need to write it out long form. So the way that this works is that I start writing out, I plug in n equals 1. So I'm going to have 1 minus 1 half. Then I plug in n equals 2 and I get plus 1 half minus 1 third. Then I plug in n equals 3 and I get plus 1 third minus 1 fourth plus 1 fourth minus 1 fifth, and I could keep going. And the very last two terms I'm going to have are 1 over n minus 1 over n plus 1. That's my nth term. Well, let's back it up to look at my n minus 1 term. If I plug n minus 1 into here, I'm going to be subtracting out 1 over n. And if I plug in n minus 1 into here, I will have added 1 over n minus 1. So let's talk about how these terms cancel. And it's actually really nifty because you see you have negative 1 half plus 1 half, negative 1 third plus 1 third, negative 1 fourth plus 1 fourth. This negative 1 fifth will cancel against a positive 1 fifth. And then let's work backwards. Here I have a negative 1 over n plus a 1 over n. And of course my 1 over n minus 1, which will actually be negated by a negative 1 over n minus 1. So these will cancel. So what I'm going to be left with is just these two terms. 1 minus 1 over n plus 1. And I'm going to take the limit now as n goes to infinity. So that's as our number of terms go to infinity. So the second term here will go to 0, and I'm left with 1. So the telescoping series that we're looking at converges, and its sum is 1. So what's interesting is that we've looked at geometric series and telescoping series so far, and we have been able to find the sum of a convergent series for geometric and telescoping. Those are the only two series that we can actually find the sum of, geometric or telescoping. And I've also just told you that telescoping is not tested on the AP exam. Therefore, if you were asked to find the sum of a series on the AP exam, it will be a geometric series.